So here is another question on graphical analysis of one-dimensional motion. So it is given here that the speed of a train increases at a constant rate a from 0 to v. Okay, initial speed 0 to final speed v at a constant rate acceleration a, and then it remains constant for a particular interval, and then from that it finally decreases to 0 at a constant rate of deceleration b, small b. If small s is the total distance covered during this entire duration, prove that the total time taken, t total, is equal to s by v plus v by 2 into 1 by a plus 1 by b. So here we'll be using the velocity time graph or speed time graph for analysis. So let us draw first the speed axis, the y-axis we'll be using, then the time axis. Okay, this is the speed or velocity, whatever you call it, and this is the time. So it is given that this object, the train, it is the speed, it increased at a constant rate a, so uniform rate a, and finally it attains a velocity of v, this, and this is the first phase. Then it remains constant, the speed remains constant. Okay, this is the constant phase for a particular interval, and then it finally decreases to 0. Okay, so let us divide this into a number of phases. This is the initial phase, t1, the acceleration phase. Then this is the second phase, the constant velocity phase, t2. And then this is the deceleration phase, retardation phase, t3. Let us name it. This is O, let's say. This is okay, this is O, this is A, this is B, this is, let's say, C, this is D, and this is E. Okay, this is region 1, this is region 2, this is region 3. Now the initial phase, okay, from OA, the acceleration is A, okay, which is the slope. Let this angle be theta 1. So here the acceleration A in the initial phase, which is tan theta 1, that is equal to AC by OC. Okay, AC is nothing but the velocity attained by the, the speed attained by the train, maximum velocity, and OC is nothing but T1. Okay, this is clear. So we can write T1 is equal to V by A. This is one equation. Next, in the third phase, let this angle be theta 2. So here the deceleration B, which will be obviously minus, but here I am just concerned on the magnitude, that will be equal to BD by D. Tan theta 2 is BD by D. Again, BD is equal to AC, which is equal to V, and DE is nothing but the duration, time duration, T3. That implies T3 is equal to V by B. Okay, it is clear up to this. These are the two important equations that will come in handy. Next, if we take this whole thing, the total distance, it is the area of this kind of, you can say, trapezium OABE, the whole thing, which we have divided into two triangular parts, OAC, the rectangular ABCD, and this is the second triangle BDE. So the total distance covered is the area of triangle OAC, which is region 1, then area of rectangle ABCD, which is region 2, then area of triangle BDE, which is region 3. So that is equal to, basically it is 1/2 base into height equal to OC into AC plus area of rectangular portion, which is AC into CD, then area of another triangular portion, which is 1/2 BD into DE, or DE into BD, base into height. Now let us substitute the values. Here OC is nothing but the velocity V. OC is equal to, OC is T1. Okay, I'm sorry, OC is equal to the time duration T1 for the first phase. Okay, OC is T1. AC is the maximum velocity V attained by the train, the speed, maximum speed attained by the train. So it is 1/2 T1 into V. Again here AC is equal to the maximum speed attained by the train, V, and CD is the time duration T2 for the constant velocity phase, okay, the middle phase, which is T2, V into T2. And again here DE is the time duration T3 for the third deceleration phase, final deceleration phase, and BD is equal to AC, which is the maximum velocity or speed attained by the train. So it is T3 into V. Okay, so that implies the total distance S. Okay, this is the total distance S, that is equal to 1/2 VT1 plus VT2 plus 1/2 VT3. Okay, this much. We can write it as by we can write it as, express it as VT2, okay, VT2 plus 1/2 V, okay, 1/2 V T1 plus T3. We are writing it like this, okay, this. Now we are bringing this V to the LHS side in the denominator, which is nothing but T2 plus 1/2 into T1 plus T3. Okay, up to this it is clear. Now T2 we can write it as S by V minus 1 by 2 into T1 plus T3. Okay, this we can write, okay, S by V minus 1/2 into T1 plus T3. This will be another important equation that will come into play, the third equation. This is here the first, the second, and the third. Now we know that the total time T total is equal to T1 plus T2 plus T3. Okay, T1 plus T2 plus T3. So the total time will be, we'll write T1 as it is, we'll write T3 as it is. in place of T2 we will write this value, which is already in terms of T1 and T3. Okay, we'll write it in terms of T1 and T3, which is S by V minus 1/2 to T1 plus T3. Okay, this. So it will be S by V plus 1/2 into T1 plus T3. Okay, this. Okay, up to this it is clear. Now go back to equation 1 and 2. T1 is equal to V by A, T3 is equal to V by V. So we'll substitute these values. S by V, this T total time, which is S by V into 1/2 into T1, which is V by A, T3, which is V by B, which is equal to S by V. V is common here, V by 2 into 1 by A. Okay, 1 by A plus 1 by V. That is the total time taken. Now here if you see the final equation that is given, which has been asked in the total distance, maximum velocity, and then in terms of acceleration and deceleration. So acceleration and deceleration, it will only come into play in region 1 involving time duration T1 and region 3 involving time duration T3. So we have to express the total time in terms of T1 and T3. Whatever we write, it should be in terms of T1 and T3. That's why I substituted T2 with parameters involving T1 and T3 and S and V. That's why we can use these expressions 1 and 2. Okay, that is V by A, V by B in place of T1 and T3. So the whole point of this question, it's a very good question, but you have to be smart enough to realize that as in the final, in this whole thing we have to prove, it is in terms of acceleration and deceleration, which comes in region 1 and 3 involving time duration T1 and T3. So these two time durations, that is T1 and T3, they are important. The expressions should be in that form. That's why I expressed T2 in terms of T1 and T3 and S and V. Okay, so this is the thing.